Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 3.2, Scalar and Factor Products. So factors, we have learned the basic idea of how to denote things using factors and what they mean on a plane. But there are more to that, and it can get up a dimension or more. It can go any kind of size or shape, but these rules still holds. With a knowledge of how to deal with factors, we now need to know how to manipulate factors. There are two main ways. One of them is called the dot product, which is the scalar product. It's defined as a dot b equals to mod a mod b cosine of theta, where theta is the angle in between the two factors. And there's also a cross product, which is defined as mod a mod b sine theta with an n hat, where n hat is a factor, a unit factor that is perpendicular to both a and b. This only works with both a and b being a factor. If they are not a factor, then if say a is a constant and a dot b or a cross b will have no meaning in any sense, because you must do them between two factors. For dot product, this will give you a scalar result, and for cross product you'll get a factor result in the normal direction. So to find the angle between a factor and the x-axis, in this case you can guess that this implies a a positional factor rather. So positional factor with x is 3, y is 2, and z is 1. In that case, we would imply to use the dot product. So recall that dot product is a dot b equals to mod a mod b, actually cos. I might have flipped the previous page. I'll check that in a bit. So with that written down, if we want to find the angle, which is theta, we want to find a and b, and to do the dot product. The dot product is not strictly algebraical, so we can do it in factor form. So if we write both factors in column form, 3, 2, and 1, dot the x-axis, which has the unit factor 1, 0, and 0, you will imply to use the unit normal, or just unit factor of x, because this implies that b mod is just 1, so that simplifies the procedure. And we want to find mod a. Mod a is the square root of 9 plus 4 plus 1 is 14, root 14, cosine of theta. Then you do the dot product. How do you do the dot product, you say? We do first term multiplied by first term, so you have 3 times 1, add 2 times 0, add 1 times 0, which gives which gives 3, is equal to root 14 cosine of angle. And so cosine of the angle is just 3 on root 14, and plug that into the calculator should give you theta, and I am not going to plug that into the calculator because I currently do not have access to one. But anyway, with that we can find the angle between a lot of things. Two vectors, a plane and a vector, a line with a dot, a line with a plane, all sorts. We're gonna talk more about that in some future video. Plus, you don't actually know what a plane is on vector space anyway. So this is scalar product or dot product. Now let's have a look at vector products. So cross product is a lot harder to apply given that you have no knowledge of matrices so far. But it's still doable in a sense. I will keep using the matrices approach because that's the best way to do it. But then if you don't understand this much, then you will definitely understand it a lot better during next chapter. For now, to do a cross product, we have initially a direction I, a direction J, and a direction K. So these three are the respective direction, unit direction X, unit direction Y, and unit direction Z. So we can define that, let's say R, which is the cross product of these two vectors, is equal to xi, where I is a vector, plus yj, where j is the vector, plus zk, where k is a vector. And they are all unit vectors respective to x direction, y direction, and z direction. So x, y, and z essentially are just coefficients or components, magnitudes. With that said, if we do the cross product, we can say that if we line up the two products, the first one on the second row and the second on the third row, just for equality's sake, we get this 3 by 3 kind of grid. And in order to find the value of I, I'm gonna actually have to do, I will have to do a bit of trick on my computer to make my editing a bit easier. Right, in order to get I, so we have I, we need to do a cross kind of manipulation down this way, then up this way. So essentially you're making a cross loop, or you can go down as well, it doesn't really matter. But remember, if you go diagonal down to the right, you add, this is very bad of me mixing my colors. So if you go down, you get 3 times 1, and if you go up, you get -1, -2, and I is equal, well, x is equal to this take away, the down take away up. So 3 times 1 take away -1 times -2. So that would give me 3 take 2, give me 1. Same for J. If I now do this, and I can hide everything with my tool. So if for, say, j, I will do this cross. So rather than 1 to -1, I do 1 to, so the row and columns without the j, I do the cross. So if you cross out a row and a column, you always get a 2 by 2 kind of grid, and you do the cross on the 2 by 2 grid, and you should get let's see, y equals to 1, take 3 times 2, this is -2, so this is -6, which should give you +7. This one, however, it's not that straightforward, because for the j, there is actually a negative coefficient to this whole thing. Again, yes, it sounds kind of stupid, it doesn't make any sense, there seems to be no pattern whatsoever, but bear with. If you do this, let's say it's defined as -y rather than, so if you do this cross thing, you get -y, and so y has to be -7. And I know what you're thinking right now, this is just doesn't make sense. I know it doesn't, but bear with, it will when it comes to factors, not factors, as of matrices. So let's do with k, go down, add, go up, subtract, and so z equals to 1 times -1 is -1, then you take away 3 times 3 is 9, gives us should I go black, equals to -1 take 9 is -10. So with that, we have 3 values. Let's see, x is 1, y is -7, 1, -7, -10. So this is x, y, and z. And this is the cross product between 1, 3, -2, and 3, -1, 1. And yes, it looks messy, doesn't make sense. You don't really need to kind of be clear at this whole algebra mess just yet. I do recommend you coming back to this video after you've gone through the matrices parts, because factors and matrices are too interlinked to separate. And yeah, essentially take this with a grain of salt right now. After the matrices, come back here, it will all make sense. For the purpose of that, I'm gonna tell you right now, what you have done there just now is to take the modulus, or the determinant of this 3 by 3 matrix. And if you've done matrix before, this will make sense now. If you haven't, wait, I will teach you determinants in the future for sure. So dot and cross products are kind of done. Cross product, again, take it with a grain of salt for now, before you've learned matrices. And once you've learned matrices, it would all make sense, and it would just, you will find it really straightforward to do whatever I've just done with the I, J, and K's. But one thing you need to know for sure, do not dot a scalar with a vector or cross a scalar with a vector. Both manipulations must be done between vectors, and a scalar cannot be involved. So do not try to a dot b dot c, because that would give you a scalar, then you can dot it a second time. However, there is a thing called the a dot b cross c, where b cross c is in brackets. That would make sense. That would actually be something very useful, and I'm going to make you do it in the questions sections. However, back to just using the dot product, it's often used to find the angles between two vectors, and that would come in handy when we want to find intersecting planes and the angle in between. I'm going to teach you that in a few videos time. You use the cross product to find the area between two vectors. So let's say you have a vector. Remember, during the imaginary or complex section, we have, I think, W vector and T vector, and I've talked about how if you add them together you get a parallelogram, and I think it's Z or something. I used the entire enclosed area over here is essentially T cross W, and that would be a n hat, and again n hat is the perpendicular vector, which in this certain plane, the xy, if I plot it in the y plane instead of the imaginary plane, then you shall get n hat as the unit z direction. Actually, in this case, it would be the negative unit z direction. I'm gonna let you experiment with that in a little bit, because vector cross product actually have a direction associated with it, and T cross W is not W cross T. Anyway, with that said, this area can be found using cross product, and there are some exam questions that does require you to use the cross product with the area to find, say, a perpendicular distance between a line and a dot, which I will tell you about. I'll teach you about it in the future, in some future videos. But also, it's important that you use this cross product for the unit normal, because most of the time you want to find a normal direction to define set plane. That I'm gonna teach you how to do more vector related stuff, because vector is a large concept to get your brain around and actually understand, and there's still a lot to go through, unlike the first two chapters. Anyway, it's time to do some questions, and I have had a lot prepared for you. And here are the questions. I've defined vector A, vector B, and vector C with the Cartesian coordinate system. I want you to find the following, because there are some relationship that I want you to figure out. A dot B versus B dot A cross C versus C cross A. These two are interesting to know and note because they are quite important. Number 3, it's out of spec. It doesn't, you do not need to know how to, you do not actually need to know about this relationship, but it's fun to practice. And if you have spare time, you've done matrices, I recommend you using matrices. If you haven't learned matrices yet, come back to question 3 after chapter 6. And then I will let you attempt this, because this will get very tedious very fast if you don't know matrices. Question 4 is a key thing to try, B and C, the angle between B and C, because I've kind of done that in the video already, and you should be able to do that. Finally, question 5. I'm gonna let you explore that, and I will give you the answer in 5, 4, 3, 2, 1. There we go. This is the end of the video, I guess. The answers are as follows. Question 1 is answer 3, but for both of them, because the result of A dot B and B dot A is commutative, which means that it's the same as summation in normal numbers, it's the same as the multiplication in normal numbers. Do it either order, doesn't matter, it's still the same number. For number 2, however, you do get 2 different answers, and if you are attentive, you might be able to notice that A cross C is actually the negative of C cross A, or vice versa. That is the relation anti-commutative, which is kind of similar to commutative. They do give the same number, except they are of different direction. For 3, it's minus 12. It is called, that relation is actually a cyclic relation of the scalar triple product, defined as A dot B cross C. So all cyclic relations follows a pattern. If you shift along one, so basically keep the dot and the cross where they are, but instead of A, B, and C, you have B, C, and A. Yeah, that would work as the same cyclic permutation and will give you the same result. However, if you do C dot B cross A, that would be the opposite, and you will get the anti-commutative effect. I'm not going to torture you with that. This is out of spec, for fun and practice. Question 4, straightforward calculator number, plug it in and just calculate. And 5, remember what I said during the video. If you did attempt this, like, I do not know what you're thinking, because triple dots doesn't exist. Do not waste your time trying to do that. The exam's not gonna make you do that, because they wouldn't trick you in the exam, but hey, we're still learning, right? Triple cross product, however, is a valid number, and you do get minus 2, minus 5, and 7. With that said, that's all for this video. Hope you've learned something. If you have any questions regarding factors, leave it in the comment section below. Tell me if I've missed something, and I will see you on my next one.